Today we are going to discuss physics, paper 12, that is MCQ, May June 2015. Question 1. Which definition is correct and uses only quantities rather than units? So among these options, we want to find which definition is correct and the definition should only contain quantities. Let's see option A. Density is mass per cubic meter. We all know the definition is right because it is mass over volume. But instead of volume, they have given it in meter. Cubic meter is a unit. So the option is incorrect. Option B, potential difference is energy per unit current. The correct definition of potential difference is energy per unit charge. Since the definition is incorrect, the answer is not option B. C. Pressure is force per unit area. The definition is correct and also both are given in quantities. So the option is C. Let's see option D as well. Speed is distance traveled per second. Again, speed given in distance, that is quantity. Second is in unit, even though definition is correct, but it is not given fully in quantities. Therefore, the option is C. Question 2. The average kinetic energy E of a gas molecule is given by the equation E is equal to 3 by 2 kT. So they're talking about the kinetic energy where T is given in absolute Kelvin temperature. What are the SI base units of K? We want to find the SI base unit of K. To do this, first what we have to do is we have to make K as the subject. So what I have done is I've taken this 2 to the other side, so it became the numerator, so 2e, 3 to the denominator, so 2e over 3 divided by t. So I got this as the subject of K. Now I have to substitute the units, SI base units of each values. Neglect the scalar quantities because they do not do anything while determining the SI base units. So energy is force into distance. Force is a derived quantity from mass and acceleration. Acceleration is also a derived quantity from length and time. So the unit of mass is kg. Acceleration's SI base unit, which is same as the SI unit, which is meter per second square. The distance is given in meter. So when you simplify the powers of the quantities, the units, you get it as kg m square s to the power minus 2. Temperature, its SI base unit is already Kelvin. So kg meter square s to the power minus 2 for the energy divided by Kelvin. Simplifying, we get kg m square s to the power minus 2. Kelvin from the denominator taken to the power, it becomes k to the power minus 1. As you can see, this answer is in option D. So the answer is D. Question 3. An analog ammeter has a pointer which moves over a scale. Following prolonged use, the pointer does not return fully to zero when the current is turned off, and the meter has become less sensitive at higher currents than it is at lower currents. Which diagram best represents the calibration graph needed to obtain an accurate current reading? So as you can see, it's an analog ammeter which has been calibrated. The two things that they are saying is, from prolonged use, the pointer does not return fully to zero. That means this analog ammeter has a zero error, which means when there is no current, that means when current reading is zero, when current reading is 0, it still gives a scale reading. So from here we can omit the options. So when current is 0, there is a reading. You can see from C and D, when the current reading is 0, there is a scale reading. So the option should be either C or D, because there is no reading here and there is no current 0 here. So you cannot identify a scale reading when the current is 0. So that's what they're saying. When current is 0, there is a reading on scale. Therefore, choice A and B are incorrect. The next part says that the meter has become less sensitive at higher currents than it is at lower currents. So we know that the option is either C or D. Let's analyze them in details. We also know that the sensitivity decreases at higher currents. So I've drawn question C and D. What I've done is I've taken equal intervals of current and then connected to the scale reading. So you can see as the scale reading increases, as the current increases, the scale reading decreases in C, option C. But in D, scale reading started from small intervals, but it is increasing. So in this case, since the scale reading is decreasing for higher currents, that means I'm talking about the gaps. The intervals of a scale readings are decreasing. We can say sensitivity decreases at higher current. Here we can say sensitivity increases at higher current. We need to find the meter in such a way the sensitivity decreases at high current. Therefore, the option is C. Question 4. The arrow represents the vector R. This direction represents the resultant vector R. Which diagram does not represent R as two perpendicular components? So when you have two vectors that is leaving from one single point, you have to complete a parallelogram. And the diagonal of that parallelogram from that particular point is going to give you the resultant. So if you consider the option A, you get to complete the parallelogram. So when you complete a parallelogram, since it's a 90-degree, the parallelogram is a rectangle. The diagonal passing through that point is the resultant. As you can see, the vector R and the resultant of option A both are in the same direction. The option A represents the vector R. Option B, as I complete, the diagonal also represents the vector R. C, when I complete the parallelogram, the resultant represents downwards, which is not similar to the given vector R. And when I complete D, it also completes my parallelogram where the diagonal represents the vector R. So the only thing, or the only option that does not represent vector R is option C. Question 5. A power supply of EMF 50 volt and negligible internal resistance is connected in series with resistors of resistance 100 ohm and 5 ohm as shown. The voltmeter measures the potential difference across the 5 ohm resistor and the ammeter measures the current in the circuit. What are the suitable ranges for the ammeter and for the voltmeter? So there is an EMF of 50 watt. There is a two resistance of 100 ohm and 5 ohm. The voltmeter reads the voltage or the PD across the 5 ohm resistor, and ammeter reads the circuit current. So to find the current, we need to know the combined resistance. As it is in series, we need to add the total resistance. 100 plus 5 gives you a combined resistance of 105 ohm. To find the current, from the Ohm's law, we know PT is equal to current into resistance. So I is equal to PT into resistance. In this case, it's going to be EMF divided by the total resistance. So EMF is 50 divided by the 105, which is 0.48. So the range stays below 0 to in the range of 0 to 1 ampere, because 0.548 is in the interval of 0 to 1 ampere. To find the voltage, since the same current passes through both resistors, we take the circuit current multiplied by the resistor. So V is equal to IR. So the current is 0.48 and resistor, the voltmeter is connected across the resistor of 5 ohm. So R is 5, it gives you 2.4, which is in the range of 0 to 3 volt. So as you can see, this option lies in D. So the answer is D. Question 6. A single sheet of aluminium foil is folded twice to produce a stack of 4 sheets. The total thickness of the stack of sheets is measured to be 0.80 plus or minus 0.02 millimeter. This measurement is made using a digital caliper with a zero error of minus 0.20 plus or minus 0.02 millimeter. What is the percentage uncertainty in the calculated thickness of a single sheet? So they are taking a thin single sheet of aluminium foil, folding it twice to get 4 stack of sheets. The thickness measured for 4 stack of sheets is 0.80 with an uncertainty of 0.02. Also, the digital caliper has a zero error of this value. We need to find the percentage uncertainty in the thickness of a single sheet. So first, we need to find the true value of the stack of sheet. So this is the value for the thickness of 4 stack of sheet. So true value of stack of 4 sheets is 0.80, and there is a zero error of minus 0.20. When your zero error is minus, you have to add it. If the zero error is positive, you need to subtract. Since my zero error is negative, I'm adding it. So I'm getting 1.00 millimeter. So this is the true value of stack of 4 sheets. Now I need to find my error in this value. Since the measurement has an error as well as the zero error also has an error, which means uncertainty, according to the addition or subtraction in your uncertainty unit, you need to add both the uncertainties. So true uncertainties in measurement, you will take the uncertainty in thickness with the uncertainty in zero error. So when you add it, it's 0.02 plus 0.02 gives you 0.04 millimeter. Now, this is for the stack of 4 sheets. We need to identify for the single sheet. So what we have to do, we have to divide our true value as well as our uncertainty by 4. So the thickness of single sheet is 1 divided by 4, you get 0.25 plus or minus uncertainty 0.04 divided by 4, you get 0.01. Percentage uncertainty in thickness, you will be dividing, it is the ratio of absolute uncertainty divided by the true value into 100%. So the uncertainty is 0.01 divided by the true value of a single sheet, that is 0.25 into 100%, which gives you 4%. Therefore, the option is C. Question 7. In an experiment to determine the acceleration of free fall g, a ball bearing is held by an electromagnet. When the current to the electromagnet is switched off, a clock starts and the ball bearing falls. After falling a distance h, the ball bearing strikes a switch to stop the clock which measures the time t of the fall. If a systematic error causes t and h to be measured incorrectly, which error must cause g to appear greater than 9.81? So there is a ball falling from rest. That means the initial velocity is 0. It's falling under the gravity. So the acceleration of free fall is g for a time t through a height of h. Now they are saying that there is a systematic error, so which causes your value of t and h to be incorrect. We need to find which variation in t and h, which combination in t and h may make your g value greater than 9.81 meter per second square. So already you know height is equal to ut plus half gt square. Since your initial speed is 0 as it is falling from rest, the u is 0, so we get this part to be 0. I'm making g as the subject. Why am I making g as the subject? Because that is the part we have to determine. So I'm making g as the subject, so it becomes 2h over t square. Okay, let's read the option A. H measured as being smaller than it actually is, and t is measured correctly. So they are saying the t value is correct, but h value is smaller. So this value, there is a variation in the height. So you can see g is directly proportional to h. So if h is smaller, g is also smaller. So which contradicts our option. So we want to find g to be greater than 9.81. In this case, our g will be lesser than 9.81. So option A is incorrect. Option B, h measured as being smaller than it actually is, t is measured as being larger than it actually is. So h is measured smaller. When h is measured smaller, g is proportional to h, g is measured smaller, while t is measured larger. So again, g is inversely proportional to t. So when t is measured larger, g becomes even more smaller. So basically the g value gets smaller than our option A. So option B is incorrect. Option C, h measured as being larger than it actually is, and t is measured as being larger than it actually is. In this case, h is greater, so g is proportional to h. G is measured greater, while your t value is greater. Since it's inversely proportional to g, your g value decreases. So there will be no change or little change in your g. I repeat again, when h is higher, your g gets higher. At the same time, your t gets larger, that time g gets smaller. So there will be a small difference or no difference in g. So that is not the option. So option C is incorrect. Option D, h is measured correctly. So there is no change in h. T is measured smaller than it actually is. So when t is smaller, t square is even more smaller. So g gets larger. So g gets larger than 9.81 meter per second square. So the option D is correct. So they are saying for g to appear greater, either h should be larger or t should be smaller than the actual values. So the answer is D. Question 8. A stone is thrown horizontally from the top of a cliff. Air resistance is negligible. Which graph shows the variation with time of the vertical component of the stone's velocity? As you can see, they are throwing a stone horizontally from the top of the cliff. Air resistance is negligible. So when they are throwing it horizontally, you can see that the horizontal speed remains constant, or the horizontal velocity remains constant. Why? Because it is not affected by gravity. The only thing that is affected by gravity is the vertical speed with an acceleration of g. So there is a constant acceleration g along the vertical component. So your acceleration should be constant. Velocity time graph is given here. So in that case, the gradient of the velocity time graph will give you the acceleration. You have to determine which graph will give you a constant acceleration. In this case, VT graph, this is constant velocity, so there is no acceleration in option A. So you can just read this. When a stone is thrown horizontally from the top of a cliff and air resistance is neglected, the vertical component of the stone's velocity is increasing from zero as the stone approaches the base of the cliff. So you can see option D, if you can take the gradient, at this point, the gradient will be constant. If you take gradient here, that means tangent to this point, the direction changes. So in this case, the gradient decreases. In option C, the gradient increases. But option D, the gradient is constant. When you take gradient of a velocity time graph, you will get a constant acceleration. So the answer is option D. Question 9. A sprinter runs a 100-meter race in a straight line. He accelerates from a starting block at a constant acceleration of 2.5 meter per second square to reach his maximum speed of 10 meter per second. So he's starting from 0 and he is accelerating with an acceleration of 2.5 meter per second until he reaches a 10 meter per second. Then he maintains the speed until he crosses the finish line. Then he maintains 10 meter per second until he finishes the race. So the area of a VT graph will give you the distance traveled by the sprinter. So the area of this one, the area of this VT graph should give you 100 meter. What time does it take the sprinter to run the race? So which means we have to find the time taken to complete the entire journey. So we have to find T2. As you can see, this area of this figure is going to be the area of the trapezium. But before that, we need to find the time t1. We know the acceleration, we know the final speed, we know the initial speed. We can find time because acceleration is the change in velocity over time. So v is 10, that is their final velocity is 10 minus initial velocity is 0 divided by t1, that is equal to your acceleration 2.5. From this, you can identify your t1 to be 4 seconds. Area, we know the area of VT graph is 100. Now we have to use the area of trapezium. So area of trapezium is half into height into the addition, sum of the parallel line. In this case, half T1. T1, in this case, the parallel lines are T2 plus this part. This is T2 minus T1. So addition of T2 plus T2 minus T1 into the height. Height is 10 meter per second. T2 plus T2 gives you 2T2 minus, we already found our T1 is 4 into 10 is equal to 100. So you can cancel 2 and 10 becomes 5. When you make your T2 as the subject, you get your answer to be 12 seconds. So the answer here is option C. Question 10. A firework rocket is fired vertically upwards. The fuel burns and produces a constant upward force on the rocket. After 5 seconds, there is no fuel left. Air resistance is negligible. What is the acceleration before and after 5 seconds? So there's a firework rocket which is fired vertically upward. So when the fuel burns and produces a constant upward force, after 5 seconds, the fuel is not there. We have to consider our air resistance to be negligible. So before 5 seconds, as the fuel burns, it produces a constant upward force. In that case, we have to take the mass to be the mass of the rocket as well as mass of the fuel. And what is the acceleration? Acceleration is equal to F into m, F by m, because force is equal to mass into acceleration by Newton's second law of motion. So when you make A as your subject, you get F over m. Now what happens? As the fuel burns, mass is decreasing. As mass is decreasing, your acceleration is increasing. After 5 seconds, when fuel is no more, that means fuel is completely burned, mass will be the mass of the rocket, which is constant. If mass is constant, your acceleration remains constant. So before 5 seconds, the value is increasing. After 5 seconds, it remains constant. So the option is C.